Hello friends, welcome back. In this tutorial, we will study about second normal form, that is 2NF. But before starting about second normal form, it is necessary to understand few definitions. So first of all, we will study about superkey. So what is a superkey? A superkey of a relation schema R is a set of attributes which is a subset of R with the property that no two tuples in any legal relation state of R will have same values. Next is key. What is a key? A key K is a superkey with the additional property that removal of any attribute from K will cause K not to be a superkey anymore. If a relation schema has more than one key, then each of the key is called a candidate key. One of the candidate keys is arbitrarily designated to be the primary key, and the others are called secondary keys. Now next is prime attribute. So what is a prime attribute? An attribute which is a member of some candidate key is called a prime attribute, and an attribute which is not prime is called non-prime attribute. Non-prime attribute is not a member of any candidate key. Now the next definition is full functional dependency. A functional dependency X implies Y is a full functional dependency if the removal of any attribute A from X means that dependency does not hold anymore. For example, consider this dependency AB implies C. AB implies C. This functional dependency is full functional dependency if neither A implies C nor B implies C holds. Partial dependency. A functional dependency X implies Y is a partial dependency if some attribute A can be removed from X and the dependency still holds. Now let us start about second normal form, that is 2NF. A relation schema R is in 2NF or in second normal form if every non-prime attribute A in R is fully functionally dependent on the primary key of R. If the primary key contains a single attribute, then there is no need to test for second normal form. The relation will definitely be in second normal form. Now consider this schema. This schema is not in second normal form. Now, name of this schema is employee project, and this schema has the combination of two attributes, employee number and project number, as a primary key. R's specify how much hours an employee works on a particular project. E name specifies employee name, P name specifies project name, and P location specifies project location. Actually, each employee can work on more than one project. So here, the primary key of this relation schema is the combination of these two attributes, employee number and project number. So after understanding the meaning of these attributes, you can find out that these three functional dependency holds. Employee number implies employee name, employee number and project number specifies or implies the number of hours employee work on a particular project. Project number implies project name and project location. So here you can see that project name and project location, they are not fully functionally dependent on the primary key. And here you can also see that employee name, this is also a non-prime attribute and it is also not fully functionally dependent on the primary key. So project name, project location and employee name, these non-prime attributes, they are not fully functionally dependent on primary key. So to normalize it in second normal form, we will decompose it into a number of second normal form relations in which non-prime attributes are associated with only that part of primary key on which they are fully functionally dependent. So here you can see that this employee project, this schema has been decomposed into these three schemas, EP1, EP2 and EP3. Now the non-prime attribute, employee name, it is fully functionally dependent on employee number. So this attribute employee name, it is associated with key employee number. Here you can see these non-prime attributes, project name and project locations. These attributes are also fully functionally dependent on attribute p number. So in EP3, what happened? These two attributes, these two non-prime attributes, project name and project location, are associated with this primary key p number. P number is the primary key of this relation schema EP3. Now you can see here Rs. This attribute is fully functionally dependent on these two, in the combination of these two attributes, employee number and project number. So in EP1 relation schema, this this attribute Rs is associated with with this primary key, which is the combination of these two attributes, employee number and project number. So in this way, this schema, which was not in second normal form, has been decomposed into these three schemas which are in second normal form. Now there is also a general definition of second normal form. So what is the general definition of a second normal form? A relation schema R is in second normal form or in 2NF if every non-prime attribute A in R is not partially dependent on any key of R. This definition can be stated as follows. A relation schema R is in second normal form if every non-prime attribute A in R is fully functionally dependent on every key of R. Actually, in general definition of second normal form, we have considered all keys. And in this definition of second normal form, we have considered only the primary key. So in the general definition of second normal form, what happens? A relation schema R is in second normal form if every non-prime attribute A in R is fully functionally dependent on every key of R.